right, welcome to our lesson on composing and decomposing in Module 1. You learned about some of the big ideas in math education. And one of the most important ones that we're going to talk about throughout this course is composing and decomposing. So our agenda for this lesson, we're going to start with composition. We're going to talk about the definitions of that. We're going to talk about our classroom applications for composing, and we're going to do some practice. And then we're going to do the same thing with decomposing, talk about definitions, classroom applications, and do some practice. So let's start with the question, what is composition? When you are in the module, you can click on the video link to see it in action. But what I want you to do is I want you to think about the word composition. Outside of math, just the word composition in general, and think about what does it mean to you. So it could be if you're going to compose a symphony, you're going to create it. If you were going to compose an email, you're going to write it, right? So there's lots of different ways to think about the word composition. But in math, what we're talking about is putting numbers together. So understanding that, for example, the number 5 is made up of 4 and 1. It's also made up of 2 and 3. It's also made up of 1 and 4, which is a little bit different than 4 and 1, right? And also, when we talk about composition and decomposition, today we're going to talk about them separately. But really, when we talk about them in practice, we almost always have to talk about them together, and you'll see why. But the idea of composition and decomposition is huge in kindergarten, first grade, our primary grades. And when you think about why that is, what we're asking our students to do here is start to develop what we call their number sense. So this idea of how numbers go together, how does our number system work? How do we compose and decompose those things? And that's the foundation of where we go for math. So we can't do addition and subtraction without composing and decomposing. We can't do multiplication and division until we've learned how to add and subtract. So we want to really build up their number sense, and the basic building block of that is what we're talking about today, composition and decomposition. So thinking about that, we're going to try it. And what I'm going to do here is I'm going to show you some tens frames. So my primary folks are probably really familiar with a tens frame. If you're not, they look like this, and they're called a tens frame because we've got 10 slots. So we've got 1, 2, 3, 4, 5 on the top, 1, 2, 3, 4, 5 on the bottom. And when you see a tens frame, it always looks like this. And again, this is starting to help us understand that idea of composition, right? That 10 is made up of 5 and 5, and there are other ways to do it. So what I'm going to do is I'm going to fill it in, and I want you to think about how many there are. And I want you to think about it without counting them one to one. So for example, if we fill in the tens frame like this, I can probably take a look at it and know that there are 6 dots, right? And the reason that I can know without having to count them is because we're all adults and we have really good number sense, and this idea of composition and decomposition is kind of baked into our understanding of the world and of math. But if we ask our students to take a look at this, you may have students when we first start something like this who have to count 1, 2, 3, 4, 5, 6, right? And the practice, the more we practice things like this, the sooner they'll start to understand, okay, wait a minute, when I look at this, I know that this is 6 because I know it's always 5 up top and 1 more is 6, right? When we do these activities with our students over and over and over again, we want to not just ask them what the answer is, but also how they found the answer. In this case, the question is, how did you see it, right? So we've got this one where we know that there's 6 because there's 5 and 1 more. We might have students that also, for example, are really good at counting by 2s, and they might say, I went 2, 4, 6, right? Let's say that we have another one that is, for example, here's another tens frame. And let's say that I have it filled in this way. And you're watching me do this, so you can count along with me. But with our students, we would have them either on a card or a whiteboard that we could flip around so they can't watch you laying it out. You either flip it around or show them the card, and you just show it to them real quick, and you say, how many are there? And also, how did you see it? So here you can see on this bottom example, we have 9, and there are some ways that I can see this. Some of our students may say, well, if the whole thing was filled up, there would be 10, but since there's one empty spot, there's 9. Some of our students might see it as here's 2, 4, 6, 8, and then one more is 9. Or we might have students that say, oh, I know that the top row is 5, so I started at 5 and then I counted and said 6, 7, 8, 9. Either way, the important thing for our students to understand is that it does not matter how you see it in terms of the answer, right? So either way, however I see it, we're going to get to 9. But there's lots of ways to compose and decompose this number to understand what 9 is. 9 is 1 less than 10. 9 is 1 more than 8. 9 is 5 and 4, right? We could also count it as 5, 6, 7, 8, 9, right? And so we could think about this as 2 and 2, or I could say 2, 4, 6, 8, all of these ways that we talked about. And if my students are able to look at these things and see them in different ways, then I know that they're starting to build that number sense and they're starting to understand that concept of composition. The important thing, again, is that we're asking our students to tell us how they saw it. One, there's 2 reasons for this. One, this gives us an idea as the teacher. It's kind of like that idea of formative assessment, right? As they're talking through these things and they're telling us how they see it, we're getting a little glimpse behind the curtain into their brains, into what they're thinking. The other super, super powerful thing about this is that our students are looking at each other's thinking. And so maybe it didn't come to me that 9 was 10 and then 1 less, right? That way. But if I hear somebody else say it, I might try to use that strategy the next time. And if our students get really comfortable with listening and thinking about and talking about their strategies, then they can use those strategies for different scenarios. I always like to talk about it this way, is thinking about a toolbox. What we're doing is we're building our students' math toolbox. And the more tools they have in that toolbox, the better equipped they'll be to tackle those problems. So, my computer locked itself. Let's see, here we go. So when we're thinking about these tens frames and we're thinking about compositions, we're thinking about 4 kind of important concepts, and it'll come in kind of this order. So developmentally. So we've got a tens frame and we're thinking about our concepts. We're thinking about things, for example, benchmark numbers. When we're looking at 10, we're thinking about the benchmark numbers 0, 1, 5, and 10. Right? Understanding 0, 1, 5, and 10 is really important because if you take a look at the context here, we've got 0 here. I need to know what 1 looks like by itself. I need to know what 5 looks like so I can use that as my benchmark, as my kind of anchoring point to think about where to go from there. Is it 5 and some more? Is it less than 5? All of those things are really important. Also, I want to talk just for a second here about this concept of 0. It's really important for our students to understand that 0 is a digit that stands in for nothing, right? Again, we know that as adults, it seems so simple, but it's really, really important that our students understand that this digit of 0 means nothing. It'll become super important when we start talking about place value as well. And I like to tell a quick little story to help everybody remember why the concept of 0 is so important. When my son was little, he wanted some cookies, and I swear this, it sounds made up, but this is a real story. He wanted some cookies, and so I said, you can have a cookie. And he said, how about 2 cookies? And I said, no, how about 1 cookie? And being the baby lawyer that he is, he said, no, how about 2? I said, buddy, here's the deal. You can have 1 cookie, or you can have 0 cookies. And he said, I'll have 0 cookies. And what does that tell us about his math knowledge? Well, he knew that he wanted something that wasn't 1, so he chose 0 because it was the other option. but he didn't have the understanding that 0 is a digit that means nothing, right? So a lesson learned that day for him pretty quickly, I'm sure, but it's an important one that our students need to know. So the other thing that we talked about is this idea of one more and one less, right? So for example, if I ask my students to talk about this number, they might tell me that I know that this is 4 because if it was 5, it would fill up the whole top row, but it's not full, it's one less, and 4 is right before 5. So that's the concept of one less. The concept of one more would be, for example, if we were talking about the number 6 that we did earlier, we would see 5 and one more. Then we move from that to this concept of 2 more and 2 less. So for example, if I'm looking at the number 7, I might have students telling me that they know it's the number 7 because it was 5 and then 2 more is 6, 7. All right? And eventually what we're going to get into here, once we've got that understanding of benchmarks, we've got 1 more, 1 less, we've got 2 more, 2 less, then we're going to start really thinking about part, whole. And that leads us into our conversation about decomposition that we'll get into here in just a second. But this is the understanding that, for example, this is the number 7. If I have the number 7, I could have 1, you could draw a table, right? 1 and 6. I might have 2 and 5, 3 and 4, and so on, right? So each number has parts. Here's the part, 1 and 6, and our whole is 7. Right? So we'll get into that a little bit more as we talk about decomposition here. So now we're going to move into thinking about decomposition. So again, just like we did with composition, I want you to think about that word just in general, outside of the context of math. What does decompose mean, right? Well, if we think about trash and garbage, right, it's breaking down. And really that's what we're asking our students to do, and we ask them to do that mathematically. So as we get into this, you'll see, like I said, we're talking about composition and decomposition kind of in isolation today. But when we talk about them in context with our students, generally we have to talk about them together. So what I want you to do is, again, when we go back to our basis, our foundation of learning math, we talk about number sense, and a huge part of that is composition, but also decomposition. So think about decomposition, this ability to break things apart. When we're talking about numbers, we're talking about breaking numbers into parts, but we also do this in geometry, where we're looking at a figure, but we have to look at the angles within that figure or that polygon. When we talk about division, we're going to talk about breaking those groups apart and things like that. So as you can see, as you go through this course, I want you to be thinking about that number sense and all those big ideas that you read about, but really thinking carefully about composition and decomposition. A lot of the time, if you have a student who's struggling in math, probably 95% of the time, that kiddo is lacking some number sense. And so that's why we're starting with these big ideas, because once we can build up our students' number sense, then we can address the problem kind of at its root and go from there. So what we're going to do now is you'll see, again, if you are in the primary grades, you may be very familiar with this graphic organizer. It looks a little bit something like this, where we've got the whole, and we've got the part and the part. Another way that you might see this that we often see in schools is it looks something like this. They call them number bonds. It's the same thing. It's just a different representation. These two things are representing the same thing. We've got a whole and we've got two parts. All right, now we're going to start talking about wholes and two parts, but we want to, again, as our students are getting this and starting to understand it, we want to have them break it apart. So it might look something like this, or we might have, and this is why teachers like this one, it's a little easier to manipulate. We might have three parts here. So what I'm going to do is I'm going to give you a number, and I want you to think about, or you can stop the video and actually write it down. Think about how you would break this up. And if you think of one way, See if you can think of 2 ways. If you think of 2 ways, see if you can think of 3 ways, right? As a teacher, we want to continue to push our students. What we don't want is, okay, we're going to break apart this number, and then they do it once and they just sit there, because we want to keep their minds active, right? Okay, so let's get started. I want to see if you can come up with at least 2 ways to show each number. So we're going to start with the number 10. Okay? What I also want you to be aware of when you're doing this is to take a look at your own work, and then eventually when you're out there doing your thing as a teacher, take a look at your students' work and look at the order that they list their pairs in. So for example, if I have a student who says, oh, 10, that's easy, it's 5 and 5, right? I want to think about, okay, what does my student know about 10? What are those concepts and those number sense ideas that my student is showing me? Well, they're showing me that they understand benchmarks, this benchmark of 5. In this case, they might also be showing me that they understand halves because they know 5 and 5, right? If I never ask my student to keep going, they might get stuck here. If I never ask my students to talk about their answers, they might get stuck here, right? But then, and I'll tell you this from experience, you'll always have a student who will say, okay, 10, that's easy. It's 0 and 10, right? We always kind of joke about this because there's always one, right, who goes 0 and 10. Well, that's important information for me as well. It shows me, again, like we just talked about, that my student understands that 0 is a digit or a quantity that means nothing. And if I have nothing as one part, I have to have everything as the other part. This is why I would continue to ask my students to give me more ways. Great. 0 and 10, you're right. It works every time. What's another way that we could do it, right? Well, it might be I might ask them to do 10 and 8. They might give me 9 and 1, right? All of those are great answers. What I want you to, again, take a look at is the order of things, because they're going to do what comes to mind right away. And if I push them to keep going a little bit further and further, then I'll be able to actually see kind of how their thinking is developing. All right. I might also challenge, once I'm able to do it in 2 parts, I might challenge my students to break it into 3 parts. So I might say, okay, fine, you want to play? We'll play, right? Here's 0. And then what other parts can I break it into? 0 and 1 and 9, right? I also could get really creative, and you will have students that do this, where they say 10 is 1 and 1 and 1 and 1 and 1 and so on, right? Again, we could be like, oh, that kid is just trying to push my buttons, but it really is an important thing. If they tell you that 10 is 1 and 1 and 1 and 1 and 1, that's a good thing, because what they're showing you is they have a basis for place value. The understanding that 10 ones and 1 10 is the same thing. We'll get into that soon. But let's go on to our next number. All right, I want you to do the same thing and see if you can come up with 2 ways to break apart and decompose the number 20. Okay? Again, I want you to take a look and be aware of the things that you're writing down first and the things that you have to push a little bit farther for. You will probably see lots of students who are able to say 10 and 10, right? How else could we break this apart, right? If I wanted to do it, for example, in 3 parts, I might say it's 10 and 5 and 5, right? So think about what our students are showing us if they do 10 and 5 and 5, that they've probably in their head broken it in half and then taken one of those 10s and broken that in half, right? There's a lot going on here. And just asking our students to show us or talk to us or to each other about how they're coming to their answers is so, so, so powerful, because it gives us an idea of where they're at, right, in their head, and where we can go next, how we can push them to that next step. Okay? Our next number that I want you to think about, we did 10 and 20, right? So there's a lot of important information in that 10 and that 20, right? We're anchoring to those 10s or groups of 10s. I want you to think about the number 16, right? See if you can come up with 2 ways to write the number 16, or break apart, decompose the number 16. I have a feeling that many of us, again, because we are adults, would break apart this number. Our first out of the gate would either be 8 and 8, because we want to do halves, or 10 and 6, right? And the reason that we would go to 10 and 6 first is because as adults, we have a really solid, hopefully, understanding of place value. So when I see the number 16, I see a 10 and I see a 6, right? Super, super, super important for our students. We want to get them to the point where they're decomposing our 2-digit numbers into 10 and something else, or a 3-digit number into hundreds, tens, and ones, right? And the reason that we want to do this is because exactly what I said, it's the basis of place value. And once we understand this composing and decomposing, then we can move into place value. And when we have a really good understanding of place value, it's going to be so much easier to do the addition, subtraction, multiplication, division strategies that we're going to talk about as we go throughout the course. All right, your next number is, we're getting a little bit harder. And again, these numbers, I'm giving them to you in this order on purpose. There's a reason I didn't start with this one, which is 34. Think about a couple of ways that you could decompose the number 34. All right, again, many of us will start after the discussion that we just had with 30 and 4 because of place value, right? This is why, though, again, we want to continue to push our students. Great, 30 and 4. What's another way that we could break that up? Well, if I want to go off of my 1 more and 1 less, I could say 1 and 33. What if I wanted my students, I might challenge them to say, okay, you're doing great breaking it into 2 parts. Can you break it into more than 2 parts? If I see this and my students kind of on their own say 10, 10, 10, and 4, wow, that's awesome, right? Really, that's an understanding of place value as well, because what they're showing me is that they understand that this 3 in the tens place means 3 tens, and then this 4 in the ones place means 4, right? 10, 10, 10, and 4. Lots and lots of ways. And again, as we're asking our students to talk about their reasoning with each other, with us, we're having lots of examples on the board. We're just giving our students more tools in their toolbox, and we understand where they're at so we can understand how to just incrementally push their thinking even further. All right, and then our last number, we're going to take it back. You'll see on the screen. We're going to think about the number 11. Gone back to the beginning, right? And if we take that number 11 and we break it into our whole and our part, if we start with our place value, we have 10 and 1, right? But the reason that we're ending on the number 11 is for a couple of reasons. For one, if we break it into 10 and 1, we're showing that we understand place value because we have a 10 and we have a 1, right? Super important. But also this particular example leads us back to that idea of 1 more, right? So in this one, we're breaking apart 10 and 1, but we're also showing that 11 is 10 and 1 more, right? And so we're able to connect these ideas for our students when we are careful and we pick our numbers in the right way, in the right order, and we build from there. So just being intentional about our examples that we're asking, being really intentional about looking at our students' work. And the only way that we can get our students to show us what they're thinking is to ask them. And so that might look like draw a picture, or it might look like explain your answer. But what we don't want to do is just stick to just the answer. We want to be having those conversations, again, so that as the teacher, I can be doing some kind of on-the-fly formative assessment, making some instructional decisions, and also so that our students can hear each other and hear each other's ideas and get used to talking about math and talking about numbers. So that is where we are going to finish this lesson off. Today we talked about and practiced composition and decomposition, and our next topic that we'll lead into is going to be place value, and we're going to think about how these concepts of composition and decomposition lead into place value. So we'll see you at the next one.